Alright, this video is going to help you find the inverse of a logarithmic equation algebraically. Now, I've kind of devised some steps. Sometimes steps are really helpful for people, but the problem is you have to remember what the steps are. So we have to practice a lot. So step 1, I have get the log alone. Step 2, switch the x and y, right? Because inverse, we're just taking the x and y and switching them. Always go like this. X and y trade places. Step 3, change the to exponential form. So if we're starting in log form, we're going to change it to the other form, and then we want to get y alone. And when we get y alone, really what we're finding is y inverse. But okay, so let's try these steps. Get the log alone. So now right here, I have log base 2 of x. That is my log. Do you see that this plus 1 is outside the log? Now, when I say outside, I'm talking about plus k. I'm talking about outside. Versus this one, check out this one. Here's my log, but really it includes this whole thing. So let me erase that. So what is it that tells me if we're inside the log or outside the log? Yes, the parentheses. Good. All right. So we have the parentheses here that tell me this is really my minus h, right? And this is my plus k when we're talking about transformations. We've been using these letters a lot. So this is the log, and I'm going to get the log all by itself. So I need to subtract 1 from both sides. So here I have y minus 1 equals log base 2 of x. All right, so first step is done. I got the log all by itself. The second step is to switch my x and y. Okay, I want to change colors. Give me a sec. Okay, so I want to say x and y, so x should go here. Everything else stays the same, and y goes here. Okay, next step is change to exponential form. So I'm going to go 2 to this power. Now notice, I used to have my arrow going this way, but that's because I had an equal sign on that side. I need to go towards the equal sign. So 2 to this whole power equals that. So if I want to change this to exponential form, I will get 2 to the x minus 1 power equals y. And then get y all by itself. Well, y is all by itself, so I don't have to worry about it. That would be the inverse of this. So we can notice that, oh yeah, we just finished graphing those. That's the parent function 2 to the y moved 1 space to the right, right? This is a horizontal shift, right and left. And we do the opposite, right? So this is the inverse. An exponential function is the inverse of a log. All right, so let's try another one together, and then I want you to do one on your own. So step 1, get the log alone. Now, the question is this log all by itself? Log base 3 of x plus 1. Is there anything that I need to get rid of? You might be tempted to subtract 1, the same as we did here. But notice, this is trapped, right? We're inside these parentheses. I can't really access that until I deal with getting it out of its box. Okay, so we have log base 3 of x plus 1. There's nothing to get rid of. This is, my whole thing is my log. So get log alone, it's already alone. Now I change to x and y. Notice I was careful to put my parentheses. I need to change to exponential form. So I'm going to take that 3. 3 is my base. 3 to the x power equals that. So 3 to the power of x equals y plus 1. And in this case, y isn't all by itself just like that. I need to subtract 1 off, and I get 3 to the x power minus 1 equals y. Now notice, I subtracted 1 from the whole thing. I didn't take 1 away from the exponent. I subtracted 1 here. All right, so notice this minus h ends up becoming a k because our x's and y's flip, just like our asymptote is going to change from being, we were pretty used to our asymptote looking like this at y equals 0. Well, now with logarithmic functions, our asymptote is going to be at x equals 0. All right, I want you to try another one. So let's bring the steps down here so you can see them better. Move this guy up. All right, So I want you to try this. Take a second, pause it. Yes, you have two things to do here, but I'm confident you can do this. So hit pause, try it. All right, so you should have gotten, this is your answer. Double check my steps with yours. So first step, I subtracted 4 from both sides, flip my x and y, change it to exponential form, and then got y all by itself by adding 3 to both sides. All right, so that would be the inverse of this, finding it algebraically. All right, I want to just do one more thing in this video, and that is identifying the parent function. And when you identify the parent function, I want you to identify it as an exponential function. So I want you to change this to exponential form. I want you to change this to exponential form and just give me the parent function. So notice, this right here is a transformation, and this right here is also a transformation. So all I want you to do is give me this right here. So as an exponent, this would say log base 6, 6 to the y equals x. That's what I'm looking for. That is my parent function. Now notice, I left my y there and my x there, and I'm not making it and finding the inverse. I'm just going to leave it like that. I know it looks a little weird, but we need this in order to set up our parent function to be able to graph a log. This is a nice way to have it so that we can graph it. So let's go ahead. So parent function again here, these are my transformations. So we have 6 to the y equals x. That's not fair. That was the same one. All right, how about this one? We just want to look at that. That's a transformation, that's a transformation. So 4 to the y equals x. 4 to the y equals x. And notice that when I'm writing this, I'm careful. 4 to the power of y, I make my y smaller and raised, so it's clear that that's my exponent. Okay? Equals x. All right, I want you to try the rest of these. Please hit pause now, and then I'll go to the answers. Hit pause. Try them. I know you can do it. It'll take you about a whole 2 seconds. All right, pause. So these are the answers you should have gotten. Oops, sorry, one of them was hiding. So 5 to the y equals x, 2 to the y equals x. Oh, my y's kind of low there, huh? Why? 5 to the y equals x. Let's try that again. Six to the y equals x. 4 to the y equals x. All right, so hopefully you can kind of see that we just want to know this chunk. These are my transformations. I just want to know this chunk in exponential form. I just want to know this chunk in exponential form. All right, so that is a skill we need for graphing. So keep that in mind for when you're watching the graphing video. Okay, thank you.